Tableau has optimized native data connections to both relational and OLAP cube data sources. This video will discuss some of the functional differences between working with cubes versus relational data sources in Tableau Desktop. Cube data sources like Microsoft Analysis Services and Oracle Essbase are often pre-aggregated and have a defined structure for business conformity. They are meant to answer a specific set of questions and therefore are not as flexible. If a field is needed, oftentimes it is best to have it architected in the cube itself. Cubes are queried using MDX instead of SQL. There are ways to extend fields that have been built into the cube with MDX, and we'll take a look at a couple examples in this video. I'm going to begin by connecting to Microsoft Analysis Services. You will enter in your server name and authenticate into that cube, and then I can select a cube on the server. Alternatively, you have the ability to connect to a local cube file. I'm going to work with a local cube file of the Superstore data source that you might have seen in other Tableau training videos, just so you'll be familiar with the types of fields that are available. This has just been architected into a cube. So I'm now going to go ahead and connect to that SuperCube data source. Notice that you don't have the ability to import all or some of that data. It's going to be connected live to that cube. Tableau is still recognizing fields as measures and dimensions. So your measures are pre-aggregated in the cube. They might be total sales or average discount. They'll all be architected into the cube. We also have our dimensions, which we use as slices of the cube to be able to slice up our different measures in a number of different ways. Notice that all hierarchies are predefined in the cube data source themselves. You don't have the ability to simply drag and drop to create any hierarchies on the fly as you would within a relational data source. But I can very simply look at, for example, sales, and maybe I'll break it down by region, and that same drag and drop process is going to hold true when connecting to a relational data source and a cube data source. Something that you'll notice as the sales field doesn't have an aggregation next to it because it's predefined in the cube that this is total sales. So clicking this drop down here to choose total using and switching an aggregation is not going to do anything because it needs to be pre-built into the cube. The quick table calculations, however, looking at percent of total, will hold true when working both cube and relational data sources. I can very easily slice and dice that data very quickly and easily. So maybe I want to look at my different product categories as well. So the drag and drop process is the same. Using show me will be the same. The only difference has to do with, for example, using the hierarchies as well as the aggregations are already predefined in the cube. Another functional difference when working with cubes versus relational data sources is the grouping functionality that's available when working with relational data sources is not available when working with cube data sources. So you might be familiar with a view that looks at, for example, total sales broken down by product category, product subcategory. We can sort it, and you see that we have some smaller items that we might not necessarily compare to something like office machines, where we might want to do some aggregation to group it up to more of a higher level, smaller items subcategory. So in a relational data source, you might hold down the shift key and multi-select some items, and normally you would see a paperclip icon that allows you to group fields in the tooltip. This is not available when working with cube data sources. One way to work around that is to create a calculated member with MDX to group those smaller items together. So what we're going to do is we're going to right click and choose create calculated members. And we're going to create a new calculated member. I'm going to call it my small items member, and I'm going to define it within the product group hierarchy. And my selected parent member is going to be the office supplies member. I'm going to go ahead and click OK. Now I could write out the MDX needed to work with the grouped fields. I'm just going to simply paste it in. As you can see, it's a little bit of work typing it in. We're looking at the product group hierarchy with the subcategory parent member, and then we're looking at labels, rubber bands, scissors, rulers, and trimmers, pens and art supplies, and envelopes. So now we've created this calculated member. When I click OK, what you'll see is there is now a small items calculated member that we can now use to group up those items with that calculated member. So we can see here up in the product group hierarchy, we have a little equal sign here where the product subcategory is to indicate that there's a calculated member there that we've created within Tableau using MDX. Another common type of calculation we might do when working with a relational data source might be some type of cohort calculation. So if I wanted to calculate the total sales for just the West region in Tableau when working with a relational data source, often what we would do is create a calculated field. That would be if the region equals West, then total sales end. Now you'll notice here in the fields for calculated fields we don't have any dimensions available. So once again we're going to need to use MDX in order to create those calculated members to compute for the West region sales. So what we'll do here is once again we'll go and create a calculated member. So I'm going to create a new calculated member. I'm going to call it my West sales, and I want it to show up in the measures hierarchy. And once again I'm just going to paste in the calculation, but what you'll see here is we're looking at within the measures hierarchy the sales field, and we have a comma, and we were computing the sales for the West region within the customer geography hierarchy. Once again, very similar to how you will see in the create calculated field dialog, is we have the check formula, and so Tableau is going to tell you if the calculation is valid, and it says it is, so I'll go ahead and click OK. And now what you'll see here is I have a West sales that I can drag and drop on my view for a member for just the West sales. So that's another way of writing MDX in order to accomplish some of the things you might use in a relational data source, one of which being the cohort calculations. So rather than writing a statement that says if region equals West, then sales end, you're going to be using that calculated member to compute the West sales. Another thing you might be doing in Tableau Desktop when working with a relational data source that shouldn't be very different is KPIs. So the KPI data type that's specified in cubes is not supported by Tableau, but you do have the ability to recreate those KPIs within Tableau very quickly and easily. So I can right click and choose to create a calculated field, and it's very simply, if the total sales, and we don't need to apply the aggregation because it's already pre-aggregated, but if total sales is greater than, let's say, $4 million, then that's considered good, else needs improvement. So I'm creating a calculated field that's a KPI, and I'm going to call this my sales KPI. Now it says that my calculation is valid. I can click OK, and now we have our sales KPI. I can then choose to place it on the color shelf. For example, with this regional sales view, I drop that on. You can now see that the southern region meets the desired target and is good. The other regions seem to need improvement in sales this quarter. Another common thing when working with Tableau is using quick filters on sheets. And this is a little different when working with cubes versus relational data sources. So for example, if I navigate to sheet 2 and wanted to add a quick filter for my product category field and click show quick filter, you'll notice that it maintains the hierarchical look and feel to it in the quick filter, which is different than a relational data source. And one benefit of this, it allows for uneven drill down. So if I select furniture, you'll notice that it allows for a total furniture sales bar and compares that to the other product subcategories, which is a little different than relational. If you did want it to be more like a relational data source where we only saw the values for furniture, office supplies, and technology, one thing that you can do is create a set. So if I right click on product category to create a set, and I can select furniture, office supplies, and technology and click OK. Now I will remove this filter here and instead use the set as a quick filter. And now you'll notice that it just has my product category fields in a calculated field. Now you'll notice that it has the furniture, office supplies, and technology product categories as a set shown as a quick filter. And now I have the option to use my list or a slider view to cycle through my different product categories. So add some more flexibility if you use sets for quick filters within Tableau. Tableau provides the ability to easily see and understand your data in your cube data sources. There are some functional differences in how Tableau leverages these sources. You can find more information covering the differences between cubes and relational sources by searching for cubes on our knowledge base.